This is 6-5, special products of binomials. The first special product we have is what's called a perfect square trinomial. A perfect square trinomial is when you have two terms being added together squared or two terms being subtracted together squared. And what that results in, if you look at this one, it would take the first term a and square it. Then you're doing plus 2 times a times b, so 2 times the a, the first term, and the second term, plus just that last one, b squared. So what it ends up looking like, depending on if you have the plus or the minus, if you notice the difference in that formula, the difference is one of them has a plus right here and one has a minus. So if it started with a plus sign, the first operation will be plus. If it starts with a subtraction sign, the first operation will be minus. So let's take a look at it. If you do x plus 3, this first one, x plus 3 in parentheses squared, that means you take the a term, the first term, x, and you square it, x squared. Then for the 2 times x times 3, that's always going to be 2 times, that 2 is going to be there every single time because the formula is twice ab. So it's going to be 2 times a, which is x, times b, which is 3. So that's where these came from. Plus the last one is that 3 squared, the last term squared. So once we do this, we calculate that, we just get the x squared from this part, plus you have the 2 times x times 3, which is 6x, plus 3 squared, which is 9. So that answer is right here. If you have the subtraction sign, it's a little bit different in the one below. So in the one below, we've got 2x minus 4 all squared. Okay, so what that means is that we're going to, because it's a binomial squared, I know it's a perfect square trinomial, and so we have the first one, a, sorry, I couldn't think what I was thinking about. First one, a, would be 2x squared. Notice it's in parentheses. This first one technically was 2, but it didn't make a difference. But for when you have a term with the coefficient, you have to put it in parentheses. Plus, here's that same 2 again. Oops, 2 times a times b. 2 times the a, which is 2x, the first term, times the b, which was negative 4, the second term. And that gets us, so we have, oops. So the 2x in parentheses squared means 2 squared x squared, which is really 4x squared, plus 2 times 2x times negative 4x, that would be negative 16x. So I'm actually going to erase my plus sign. I should have known that because that's the formula that this operation will be, the first operation will be subtraction because we started with a subtraction sign. And then last would be plus 16. So this is the only thing different about having the subtraction sign in between. Now the other possibility is difference of two squares. To be a difference of two squares, they'd have to have different signs being multiplied to each other. So remember, perfect square trinomial, I'll write it up here, was a plus b in parentheses squared, or a minus b in parentheses squared. This one means a plus b times a plus b, and this means a minus b times a minus b. Difference of squares means that we will have different signs. This one's a plus, and this is a minus. So they have different signs. It's still a binomial times another binomial, but different signs. Keep in mind the a's would be the same number or variable, like for instance if I had x, and the b would be the same number or variable, let's use 4, and so one of them would have a plus sign and one would have a minus sign. The result is always going to be that first term, the a squared, so in my case x squared, minus whatever the b squared is, well 4 squared, which is 16. So this results in x squared minus 16. Answer the following. Which type of special product will result in this? Now, since we have a subtraction sign here, and it's not 3 terms, it's not a trinomial, so it can't be a perfect square trinomial, therefore it's going to be a difference of 2 squares. Because when we multiplied, this actually started out as x minus 8y times x plus 8y. I know that because I just took the square root of each one. Square root of x squared is x, square root of 64, y squared is 8y. And if you multiply this minus times this plus, at one point you'll end up with a negative. Which type of product will result from multiplying a binomial times itself? This is like k squared minus 3 squared. Well, it's not difference of two squares, so therefore we'll end with a perfect square trinomial. Why is x plus 4 times x plus 4 not a difference of two squares? Well, first of all, they don't have different signs. One's a plus and one's a minus. That's one reason. Not different signs. Also, if you actually multiply that out using FOIL or using our shortcut, or perfect square trinomial shortcut, you'd end up with x squared plus 8x, 2 times 4 times x, 2 times ab really. And then last is plus b squared, which would be 4 squared is 16. State whether the products will form a difference of two squares or a perfect square trinomial. So the first one, we have two different signs, so it's a difference of two squares. In the next one, we'd have a perfect square trinomial, both plus signs. And in the other one, they're both minus, subtraction, so it's another perfect square trinomial. All right, let's take a look at some examples. So example 1a, in parentheses, x plus 3 squared. Okay, so it's a plus sign. It's really this, a plus b squared, which is a squared plus 2ab plus b squared. So I'm just going to plug in what I know. Since a is x, I could do parentheses, but it's not going to matter for that because there's no coefficient, or the coefficient's 1, plus 2ab, 2 times x times 3, plus b squared, 3 squared. So we get x squared plus 6x plus 9. So it's really faster than FOIL once you get good at it. Okay, our next one, it's another going to result in a perfect square trinomial. So I'm going to keep in mind it's a plus b squared equals a squared plus 2ab plus b squared. So I'm going to take my a, which is 3x, and the b is 2y. So a squared, 3x squared, plus 2 times 3x times 2y, plus my b squared, which is my 2y squared. Remember, we replaced with parentheses, so this is going to give me a different answer. It's not 3x squared as my answer. It would be 9x squared, plus 2 times 3x is 6x, times 2y is 12xy. So multiply the coefficients, keep the base. There are no exponents to add. Plus, again, distribute that. It's going to be that power is being distributed to both numbers and variables in there. So we end up with 2 squared, which is not 2, 4y squared. And that's our answer. And for this one, again, it's going to be a plus b squared, which is equal to a squared plus 2ab plus b squared. So my a is 5, my b is m squared. So I have 5 squared plus 2 times 5 times m squared plus m squared squared. 25 plus 10m squared plus m to the 4th. If I rewrite that in standard form, it'd be m to the 4th plus 10m squared plus 25. You might have kind of already realized this was written sort of backwards to begin with. We would normally write that as m squared plus 5. So we had to end up reversing our. Okay, now we have a subtraction sign in here. So it's really the same thing that we've been doing, except that it's going to be minus 2ab. So it's a squared minus 2ab plus b squared. So now we have, let's see, our a is x, our b is 6. So I have a squared, which is x squared, minus 2 times a, which is x, times b is 6, plus 6 squared. So that results in x squared minus 12x plus 36. Our next one, my a is 4m, my b is 10. So we're going to get a squared minus 2ab plus b squared. A squared is going to be in parentheses 4m, because it has a coefficient, squared, minus 2 times 4m times 10 plus 10 squared. So we get 16m squared minus 80m plus 100. Okay, now we have, oops, our A is 2, our B is 5. So let's do this again. A squared minus 2ab plus b squared. So I know that minus is there because I have a minus in the problem. So let's see. Oops, A was 2x, sorry, and B was 5y. Okay, back to what I'm doing. 2x squared minus 2 times 2x, 5y, plus 5y squared. 4x squared minus 2 times 2 is 4 times 5 is 20xy. Multiply the coefficients, keep the bases. Normally add the exponents, but there weren't any, so plus 25y squared. And the last one, A is 7. I already know this is kind of written backwards, so we'll have to rearrange when we're done. And B is r to the third. So a squared minus 2ab plus b squared. 7 squared, put that in parentheses if you want, minus 2 times 7 times r to the third plus r to the third squared. Power to a power at the end there is going to be multiply, so it's going to be r to the 6th. Let's go right in order. I don't know what I'm doing. 2 times 7 is 14 times r cubed, negative 14 r to the third. Now I have to rearrange. So it's r to the 6th, then it's negative 14 r to the third. That one's a degree of 3, so it goes in the middle, and it's a positive 49. Be careful when you rearrange. Check the sign to the left. Now these are a difference of two squares. A difference of two squares is going to be a squared minus b squared. So the a in this case is x, the b is 4. So we're going to do x squared minus 4 squared, which is 16. Next one, I have my a is p squared, my b is 8q, and I know it's difference of two squares since they have different signs. So it's going to be a squared minus b squared. Well, a squared is p squared minus b squared, which is 8q squared. Careful those parentheses. Now here I have p to the second to the second. That's a power to a power. So I multiply p to the 4th minus, and this one I'm going to distribute the 2 to both the 8 and the q. So we get 64q squared. And the last one here, we do my a is 10, b is b, that's confusing, and then a squared minus b squared. So 10 squared minus b squared results in 100 minus b squared, or in standard form you can rewrite that as negative b squared plus 100.